Hello friends, welcome you all. So today's topic is equivalence of two finite automata. So you may in your any university exam, in any competitive exam, sometimes this is very common question. Like if you are given two finite automata and you are asked to compare these two, like whether they are the same or not, or now, what do you mean by same two finite automata? If they are accepting the same language, then they are considered as same. If both the finite automata are accepting the same string and rejecting the same string, that means they are accepting the same language. Then we can say these two finite automatas are equivalent. So today we will see how to check this equivalence. So there is one method, and that method I will tell you. See, I have taken two DFA here, and you can see the structure of both the DFAs is different. Like this one is having three states, and this one having four states. So let us check whether they are same or not. So let's see how to check this equivalence. So for this, we can consider here in every DFA there may be two types of states. Some are final states. So I will represent them as a final state (FS), and some are intermediate state. Some are intermediate state. So any state which is not final state, that we will consider as intermediate state. If initial state is not final state, then it is also considered as a intermediate state. So in this case, in both the machine, initial state is final state, so it will be considered as final state only. But if initial state is not even final state, then it will be considered as intermediate state, right? So these thing we will use to compare both these finite automata. Now I will tell you how it is done. So we can start with both finite automata like this. So we can create one table here, transition table, and in this how we are going to make entries. So see, in both the finite automatas, two inputs are there, C and D. Here also C and D. So I can take one input as C and other input as D. Now take the initial states of both the finite automata and combine them. And so you will get one state here, Q1, Q4. How we have got this? So these are the initial states of both the finite automata. So we have combined these two states and we have got Q1, Q4. Q1, Q4. Now we need to check this particular state, the input, when we apply input C on this state, then where we will move, and if we apply D on this state, then where we will move. So that we need to check out. So now you can see how to check it. Now for this, as these are combined state of two different states, so you can see the transition of C, input C, for both the states. So on Q1, if we are getting sorry, on Q1, if we are applying C, then we are staying on Q1. So I can write it like this, Q1. And on Q4, if we apply C, so we are staying on Q4 itself. So again I can write Q4. So this is again one combined state. So this means on Q1, Q4, if we are applying C, so we will stay on the same state. Now, what about D, input D? So on on Q1, if we are applying D, so we are moving to Q2. We are moving to Q2. And on Q4, if we are applying D, so we are moving to Q5. Moving to Q5. That means On applying D on Q1, Q4, we will move to Q2, Q5. Now you can see my friends, here both these are final states. Both these are final states. And both these are non-final or intermediate state. Intermediate state. Now do this until you are getting any non-matching pair, or until new states are not being created. Now you can see we started with Q1, Q4. So here we got Q1, Q4 itself. Now new the state is this Q2, Q5. So now we will explore this state. So we can add it here Q2, Q5, and then we can repeat the same process on Q2, Q5. So on Q2, if we are applying C, so we are moving to Q3, and on Q5, if we are applying C, so we are moving to Q6. Now on Q2, if we are applying D, so we are going back to Q1, and on Q5, if we are applying D, so we are going back to Q4. So now again you can check both of these are intermediate state. This is intermediate state, this is intermediate state. So these are IS. Intermediate state, intermediate state. And these are both the final states are there. So again we have got the same matching pair. Both these words should be matching, right? Both these states must be matching. Now we are getting always the matching pair, and now one more new state is generated there, which is Q3, Q6. Q3, Q6. Now we will apply the same process on Q3, Q6. As we have already seen Q1, Q4, we have already seen Q2, Q5. Now the new state is Q3, Q6. So we will apply the same process on Q3, Q6. Now on Q3, if we are applying C, so we are moving to Q2. On Q6, if we are applying C, so we are moving to Q7. And on Q3, if we are applying D, so we are staying on Q3. On Q6, if we are applying D, so we are staying on Q6 itself. So now again you can see both these are non-final or intermediate state. These are also intermediate state. Now you can see this state is already considered. Now new state is there 9 to Q2, Q7. So again we will start with Q2, Q7 and apply the same process on this also, right? Now on Q2, if we are applying C on Q2, if we are applying C, so we are moving to Q3. And on Q7, if we are applying C, so we are moving to Q6. Now on Q2, if we are applying D, so we are moving to Q1. And on Q7, if we are applying D, so we are moving to Q4. Now you can see Q1, Q4 we have applied, we have explored. Q2, Q5 we have explored. Q3, Q6 we have explored. Q2, Q7 we have explored. Now no new state is there. And now finally check these two pairs. So this is again intermediate state. And this is again final state and final state. Now you can see, now we have considered all the states, and now no new states are being created. Now, and we have got all matching pair here. All matching pair FSFS, ISIS, ISIS, FSFS, ISIS, 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 FSFS. So that means all matching pairs are there, and we have no new states are remaining now. So we can declare these two are same. These two are same. So I hope friends this is very much clear to all of you. Now if you have any doubt, you can ask me in comments. I will definitely reply your comments. Now I will take one more example. So friends, now we consider these two finite automatas. Although from the structure they are looks like same, but let's check whether they are same or not, right? So we can start with the same process like we did with the previous example. So I can have two input symbols here again, C and D, and I can start with Q1 and Q3 as these two are initial states. So now we will consider both the input on that state and then write their transitions and check the pair. So on Q1, if we are applying C, so we are getting to Q2. And on Q3, if we are applying C, so we are getting to Q3 itself. Now on Q1, if we are applying D, so we are on Q1 itself. And on Q3, if we are applying D, so we are going to Q4. Now you can see, friends, this is no I intermediate state and this is final state. So no need to check it further because we have got one invalid pair. So we can declare these are not equal. These are not equal. But I will completely make this table. So here also we have got Q1 and Q4, which is again non-matching pair. So this is Fs and Is. Again non-matching pair, again non-matching pair. So now new state is there Qt, Q2, Q3, Q2, Q3. So on Q2, if we apply C, so we will move to Q1. And on Q3, if we apply C, so we move to Q4. Now on Q3, Q2, if we apply D, so we are Q2 itself, on Q2 itself. And on Q3, if we apply C, so we are on Q3. Sorry, if we apply D, so we are moving to Q4. Q4. So that means again we have Fs and Is pair. Again we have Is and Is pair. Now new states we have considered this state completely, this state completely. Now new state is this, new state is this. So we will consider Q1, Q4. So now on Q1, if we are applying C, so we are going to Q2. On Q4, if we are applying C, so we are going to Q4 itself. Now on Q1, if we are applying D, so we are staying on Q1. On Q4, if we are applying D, so we are moving to Q3. Now no new state is generated here, and again you can see these are IS matching pair, and these are non-matching pair Fs. Oh, sorry, Fs and Fs, both matching pair. Right now, this any new pair. So this we have considered. This we have considered. This we have considered. This we have considered. This only remains. So I can use this now. So Q2, Q4. Now on Q2, if we are applying C, so we are moving to Q1. On Q4, if we are applying C, so we are staying on Q4. On Q2, if we are applying D, so we are staying on Q2. But on Q4, if we are applying D, so we are moving to Q3. So both these states are already created. So no new states are now. So we can complete it. So now you can see Q1, Q4 again non-matching pair Fs and Is, and here also Is and Fs. So now no new no new state is being generated. So we can stop here. Now you can see one non-matching, two non-matching, three non-matching, four non-matching, five non-matching pair we got. So even if we get one non-matching pair, then we can decide yes, these are not equal. But for explanation purpose, I just created all these states so that it would be very clear to all of you, right? So I hope it is clear to all of you. And if you have any doubt, you can again write me in comments, and definitely I will reply your comments. Thank you so much.